So WQ7T here, and I have a very enhanced version of a Panadapter program. The original program was called FreqShow, and written by Tony DeCola, and I stumbled across that program and was real interested in trying something like this. The program code was very clean. I don't know Python. I'm not going to claim to know Python, but it looked really understandable. I needed more functionality than the original program had, so I got into it and started adding things to it, and here's the result. So what we have is for the Raspberry Pi and the RTL-SDR dongle. It uses these use the 820T2 tuner. I have a 2.8-inch Pi TFT capacitive touch screen by Adafruit Industries, and the Raspberry Pi image that I built for this one is quite specific to this screen. I do not want to do a upgrade like a sudo apt-get upgrade to this guy. If I do, I'm going to at least lose the ability to use the touch screen. This one is the 7-inch Pi Foundation 800 by 480 TFT capacitive touch screen. And so I've got two different versions, and the reason that I did this is because this particular little screen has a case you can put it in, as well as this one. It has a stand for the display, and that's the whole reason that I did these two displays. If I was going to build a box to house the display, which I originally intended to do, I wouldn't have needed to be kind of restricted to either one of these screens, but that's why I chose what I did here. I kind of like this little one. However, like I say, it's really specific to this screen. Now, the original FreqShow had the enhanced version retains all the things that the original FreqShow did, all the functions like, oops, you can see full screen. You can do full screen. You can also do a waterfall, and you can do the same thing full screen with that too. So I'll put this back. Okay, now and then of course there were a few things you could set, like center frequency, sample rate, and the minimum and maximum values for your scaling and gain. So those were the things that you could set with the original program. I've added several more things, like a zoom factor. You can zoom in. You have a tuning rate, FFT averaging, local oscillator offset, frequency correction, windowing functions, and swap IQ or peak or average. So I'll go through those. So now some of the new functions are you can control right from the screen level like this, which is pretty handy to be able to do. The other thing you can do is wait till the carrier pops back up here, is I can control the frequency here. Yeah, let me get it back to where it's supposed to be there. There we go. So that just makes it easy to make adjustments from the front screen. This one does the same thing. So let's see. I'm going to zoom in a little bit more here. By the way, the this zoom factor that I put in. Oh. Okay, I'm going to go to 25 kilohertz. And so you see I have the ability to zoom in. With this guy, 800 pixels across the screen, I can go up to down to 25 kilohertz. On this it's 320 pixels across the screen, I can go down to 10 kilohertz on this screen for the full span. And so what I'm doing is when I do the FFT, I tell it how many frequency bins that I want, and in order to do this, and then I cut off everything except for what I want to display for the screen, so on either side. So that's how I do the zoom factors, is math. Anyway, so it does give me the ability to do that. When I do this, when I tune, you can actually see the frequencies go up and down here, which is the way what we wanted to be able to do, of course, and with the ability to see the detail. The other thing that I can, well, many things, one of the other things we can do is this FFT average. Right now it's set to 3. I'm going to set it, oops, I'm going to set it back, or set it to 10. And what I do is I set an array depth of 10, and as I tune, when my peak is set to true, you can see how wide the carrier gets, and then it narrows down as I tune. When he comes back here, we'll be able to see it again. There we go. So you can see what happens in it's a peak persistence is essentially what we end up with an array depth of 10. So the other thing that I can do is if I set that peaking function to false, I get a whole different thing here, and that is, first thing you notice is the noise looks like it went down. That's because we're averaging each pixel for 10 scans. And so when I get a decent carrier back here, and when I tune, because it's averaging, the level of the carrier drops considerably. And I'm just waiting for a carrier to come back here. And when I stop, then the carrier starts coming back up. But because I'm averaging 10 scans, when I tune, the whole average goes down. That's why you see it go lower. Anyway, it's a very handy thing, especially for carriers that are kind of constant. So I'm going to set that back to true to look at peaks, and I'm also going to set it back to 3. Kind of like it right there. So one of the other things I can do is when you do an FFT on the dongle, from the output of the dongle, basically I dropped the original program dropped off the 2 end values and to remove the DC offset, but there's still a little pip involved, or still a pip there. So what I have a local oscillator offset, so what I'm going to do is set that to 0 to show you what happens. And see, there's the pip right there. And I don't like that. Irregardless, if I tune here, the pip stays there, so I don't like that. And so I want to drive it off the screen, so I do that with what it is the local oscillator feed through of the dongle. So what I'm going to do is drive it off, and I'm going to set it to go 30 kilohertz off the screen. So there it's gone, and I like it better that way. Okay, let's see what else here. Let's see, I have the ability to do frequency correction. It's not much of a issue with these new temperature compensated crystal oscillators in the dongles. And I recommend that that's what you buy. It's not even an issue, but if I was using one of the original dongles that I bought out of Hong Kong, they're not temperature compensated. Definitely need to use a frequency correction there. The other thing that I've got is a choice between 9 different windowing functions. So I have boxcar, hand, Hamming, Blackman, Blackman Harris, Bartlett, Barthan, Nuttall, and Kaiser. And these windowing functions are really important. They help reduce some of the what they call side lobe leakage from the frequency bin, the samples of the frequency bin before you do the FFT. And so you need to apply this filter to that information. Each one of those bins has 8,192 samples, and so I take the filter and sample it the same 8,192, and then multiply those to apply the filter, and then I can do the FFT. But I have to do it to each one of the frequency bins. So if I happen to select Kaiser, one of the additional things that comes up on the screen is a beta setting, and so you have the ability to set the Kaiser windowing function as variable based on this beta factor, and it can be anywhere between 0 and 100. So you can experiment with that. Normally going to be using kind of lower numbers, not real high, but at any rate, it's something that's kind of fun to play with if you want to do that. I normally have this thing set to Nuttall. That's what I set the default to. Let's see. I don't know if there's anything more that's real significant that I need to go through here. I'm just looking here. Well, I guess so. You can set. Yeah, I think I said the minimum, maximum values on the graph there. The graph is something that I added as well. So anyway, there you go. It does give you the scale factor, and it tells you whether your FFT peaks, you're doing FT peaks on the screen, or if you set this false, it also tells you whether you're doing the averaging. So it lets you know that right on the screen. So set that back. So there you go. There's the WQ7T enhanced version of FreqShow.